Welcome to Study Loop.
This is the answer to Chapter 12, problem number 81 from the Smith Organic Chemistry textbook. And in this problem, we are told, we're given molecule X, which I've drawn here, and we're told that Sharpless epoxidation of allylic alcohol X forms compound Y. And then we're told the treatment of Y with sodium hydroxide and thiophenol in alcohol and water forms Z, and we're given Z as well. And so we're asked to identify the structure of Y and draw a mechanism for the conversion of Y to Z. And we're also asked to account for the stereochemistry of the stereocenters in Z. Okay, so taking this a piece at a time, the first thing I'm going to do is going to be to draw the product of the Sharpless epoxidation using plus DET. And so that is going to look like this. So using the plus DET is going to put the epoxide here on wedges. And so this is molecule Y that we were asked to come up with the structure for. So this is Y. And we can talk about the first stereogenic center that's going to be in our product here. So this bond is going to hold through all the way to our product, and it's going to be wedged in our product just as it is here in Y. And so the reason for that is we just set that stereo center by using the Sharpless conditions. Okay, so then moving on. So we need a stepwise mechanism to get from Y to Z. So starting here with Y, we treat Y with sodium hydroxide. So that is going to deprotonate this alcohol like this. Okay. And so the product after that is going to look like this. Oops. All right. There we go. That's a little better. Okay, so here is our product post deprotonation of this alcohol. So this alcohol has 3 lone pairs. I guess it's not an alcohol anymore. So this oxygen has 3 lone pairs and a negative charge. And so that's going to allow it to act as a nucleophile and attack the epoxide. And because of the stereochemistry that the epoxide has, as a result of the Sharpless epoxidation, this oxygen is going to have to do a backside attack. And so that's going to look like this. And our product after that will be this. Okay, and so now, as I said before, so now we can see this oxygen that has a negative charge that is going to shortly be protonated to be just an alcohol. We can see where its stereochemistry derives from, and we can also see where the stereochemistry on our newly formed epoxide, which is also going to end up being an alcohol, we can see where that stereochemistry comes from. So the Sharpless epoxidation sets the stereocenters of the epoxide, which forces the oxygen nucleophile to do a backside attack. And so our newly formed epoxide has determined stereochemistry as well. And so, as I said, the next thing that's going to happen, so this is a water alcohol mixture. We were told that this reaction is taking place in. So we can just call upon some water here. And this oxygen can be protonated to an alcohol. Okay. And so the next thing that's going to happen is going to be, so we have this thiophenol. It's too long of an arrow. So we have this thiophenol, and in the presence of base, which there is base in here. So let's see, C6H5SH, in the presence of sodium hydroxide. Oh, too high. All right, so I'm just going to write it under the arrow. It's fine. So in the presence of sodium hydroxide is going to be deprotonated. This is going to be a thiol nucleophile. So the sulfur has an extra lone pair and it has a negative charge. And so it's going to act as a nucleophile here. And it's going to attack the epoxide that we just formed. And because there's sodium hydroxide floating around, this is going to be considered basic conditions. And so under basic conditions, a nucleophile is going to attack the less substituted side of an epoxide, just as I've drawn here. And so we will end up with this. And this oxygen has an extra lone pair and has a negative charge. And so the very last thing that we need to do is protonate that oxygen. So again, this is an alcohol water mixture. So we can just call on some water to get that job done. Draw a long arrow to here. And so that oxygen is protonated now and is an alcohol. And so that gets us to our final product, Z, that we were asked to make. So here it is. Okay, and so again, we've kind of accounted for the stereochemistries in Z as we went, but just to review, so the first alcohol, the wedged alcohol, that is a result of the Sharpless epoxidation setting the stereochemistry of the epoxide in the first step, going from X to Y. And then in the course of going from Y to Z, our second step is backside attack by an appended oxygen nucleophile. And so that is what sets the stereochemistry of that second alcohol, the one that's on a dash. So when the epoxide that oxygen nucleophile attack forms is opened 2 steps later, the alcohol ends up with that dashed stereochemistry. And so that's the answer to chapter 12, problem number 81.